Randomized mechanisms. All of our discussion so far considered only deterministic mechanisms. It is quite natural to allow also randomized mechanisms. Such mechanisms would be allowed to produce a distribution over alternatives and a distribution over payments. Alternatively, but specifying slightly more structure, we can allow distributions over deterministic mechanisms. This will allow us to distinguish between the two notions of incentive compatibility. Definition 9.38. A randomized mechanism is a distribution over deterministic mechanisms, all with the same players types spaces Vi and the outcome space A. A randomized mechanism is incentive compatible in the universe sense if every deterministic mechanism in the support is incentive compatible. A randomized mechanism is incentive compatible in expectation if truth is a dominant strategy in the game induced by expectation. That is, if for all I, all Vi, V minus I, and Vi prime, we have that expectations of Vi of A minus Pi, which is greater than equals to the expectations of Vi of A prime minus Pi prime, where the tuple API and A prime Pi prime are random variables, denoting the outcome and payment when I bits, respectively Vi and Vi prime, and E dot denotes expectation over the randomization of the mechanism. It is clear that incentive compatibility in the universal sense implies incentive compatibility in expectation. For most purposes, incentive compatibility in expectation seems to be the more natural requirement. The universal definition is important if players are not risk neutral, which we do not consider in this chapter, or if the mechanism's internal randomization is not completely hidden from the players. As we will see in chapters 12 and 13, randomized mechanisms can often be useful and achieve more than deterministic ones. We will now characterize randomized incentive compatible mechanisms over single parameter domains. Recall the single parameter setting and the notations from section 9.5.4. We will denote the probability that I wins by Wi of Vi V minus I equals to the probability of F of Vi V minus I is in Wi, probability taken over the randomization of the mechanism, and we'll use Pi of Vi V minus I to directly denote the expected payment of I. In this notation, the utility of player I with valuation Vi when declaring Vi prime is Vi times W of Vi prime V minus I minus Pi of Vi prime V minus I. For ease of notation, we will focus on normalized mechanisms in which the lowest bit Vi to the 0 equals to 2 to the 0, loses completely Wi of Vi to the 0 V minus I equals to 0, and pays nothing Pi of Vi to the 0 V minus I equals to 0. Theorem 9.39. A normalized randomized mechanism in a single parameter domain is incentive compatible in expectation if and only if for every I and every fixed V minus I we have that 1. The function Wi of Vi V minus I is monotonically non-decreasing in Vi, and 2. Pi of Vi V minus I equals to Vi times W of Vi V minus I minus the integration of W of t V minus I dt, integrating starting from t equals to Vi to the 0 to Vi. Proof. In the proof, we will simply simplify notation by removing the index I and the fixed argument V minus I everywhere in this notation to show incentive compatibility. we need to establish that VW of V minus P of V is greater than or equals to VW of V prime minus P of V prime for every V prime. Plugging in the formula for P, we get the integrations of Wt dt, integrating starting from t equals to V to the 0 to V, which is greater than or equals to the integrations of Wt dt minus the multiplications of the term V prime minus V and W of V prime, integrating starting from t starting as V to the 0 to V prime. For V prime which is greater than V, this is equivalent to V prime minus V times W of V prime, which is greater than or equals to the integrations of Wt dt, integrating starting from t equals to V to t equals to V prime, which is true due to the monotonicity of W. For V prime less than V, we get V minus V prime times W of V prime, which is less than or equals to the integrations of Wt dt, integrating starting from t equals to V prime to t equals to V, which again is true due to the monotonicity of W. In the other direction, combining the incentive constraint at V, Vw of V minus P of V is greater than or equals to Vw of V prime minus P of V prime. With the incentive constraint at V prime times W of V minus P of V, which is less than or equals to V prime times W of V prime minus P of V prime. And subtracting the inequalities, we get the term multiplied by V prime minus V and W of V. The result is less than or equals to V prime minus V times W of V prime, which implies monotonicity of W. To derive the formula for P, we can rearrange the two incentive constraints as V times the difference of W of V prime minus W of V. The result is less than or equals to P of V prime minus P of V, which is less than or equals to V prime times W of V prime minus W of V. Now, by letting V prime equals to V plus epsilon, dividing throughout by epsilon, and taking the limit, both sides approach the same value, V dot dW over dV, and we get dP over dV equals to V dot dW over dV. Thus, taking into account the normalization condition P of V to the 0 equals to 0, we have that P of Vi equals to the integrations of V times W prime of V dV, integrating starting with V equals to V to the 0 to V equals to Vi, and integrating by parts completes the proof. This seems to require the differentiability of W, but as W is monotone, this holds almost everywhere, which suffices since we immediately integrate. We should point out explicitly that the randomization in a randomized mechanism is completely controlled by the mechanism designer and has nothing to do with any distributional assumptions on players' valuations, as will be discussed in the next section.